Hi, welcome to my YouTube channel Easy Aviation. Here we discuss about the short simple topic about the aviation field. Today's topic of discussion is weight and balancing of an aircraft or CG calculation of an aircraft. So weight, as we know, it's any object having a mass getting pulled by gravity. So weight of the body is given by mass into gravity. But when we are talking about the balancing of an object or balancing of an aircraft, there are two terminologies, that is empty weight and all of weight, which needs to be discussed in detail and needs to be clarified. On basis of them only we'll able to understand how the center of gravity is being calculated of an aircraft. So first we'll discuss about the empty weight. Empty weight, let's say an aircraft is coming out from the manufacturing, so there are objects which are fitted on the aircraft which will not be removed in future when aircraft is going for a specific mission. It same goes for the helicopter. So some objects, I'll just objectify like comm set. Any mission the aircraft is going, this will never be removed. If there is a radar which is fitted, it will not be removed. Engines definitely, fuselage weight, fuselage, APU. So these all are the items. Very important. There are hydraulic fluids which are there in the hydraulic packages, hydraulic reservoir, and they will be the part of the empty weight of the aircraft. When we discuss about the all of weight, there are items which are mission oriented items which are being carried by the aircraft when the aircraft is getting ready for a specific mission. I'll just give an example, like crew, the pilot, co-pilots, if it is going for a specific mission, if it is going for a combat free fall CFF, or it is going for combat missions, if it is going for a search and rescue mission, the weight of the gear which they are carrying, weight of the fuel as depending on the mission the aircraft is going, weight for any specific, like aircraft is going for slithering, let's say it's specific to the helicopters, there is a slithering boom which is being attached, the weight of that part. So when we add all this specific mission oriented gears to the empty weight, let's say empty weight is X and this is Y, so all of weight will be X plus Y, where X is always constant and it is provided by the OEM or the manufacturer. So I'll summarize this page. There is a weight of aircraft which is known as empty weight, which is given by the manufacturer OEM, consists of all the fixed items which are fitted on the aircraft and will not be removed for any specific mission. And there is all of weight, which is the addition of empty weight and mission oriented, I'll say mission oriented gears. So all of weight is keep changing, and the pilot, captain of the aircraft, always calculate all of weight before proceeding for any sorties. Now coming to the next part, which is known as balancing. So as we all know, a body, if suspended in an air, I'll just take a slab, a body suspending in an air has to be balanced at a specific point. That means all the weight of the body is acting at a central point. So let's say it's a square slab, so the center of gravity is at the center, and if we hold the slab from the center, the body will balance. Similarly, in an aircraft, there is a point known as center of gravity at which the complete aircraft can be balanced. So if we say this is the point, I'll just mark, this is the point, this is the CG of the aircraft, then to mention this point we need to have a reference. So generally the reference is taken from the tip of the nose somewhere, and for the calculation purpose it can be taken from the center of the body. So let's say the length of the aircraft is L, so at point from the reference there is a point X at which the center of gravity if the aircraft is balanced at this point. This is when you say longitudinally. If we say laterally, there is a center line and there is aircraft, if it is equally balanced, or the weight is equally distributed among this symmetric structure, then there should be a point at the center at which the aircraft should be balanced laterally. Generally it could be some or some inches either side, that is okay. And same if we go the vertically, so if this is the axis, it can be a little bit above, it will little bit low, depending on the weight distribution of the body. So this is the explanation that empty weight, let's say the empty weight of an aircraft is 4500 kgs empty weight. This is the weight which is provided by the OEM manufacturer, and which is always there in the manual of the aircraft. And it is always given, like I'll say longitudinally, then the CG and XX direction, I'll take it as an X direction, then it will be given as let's say 20 meters. I'll just take the length of the aircraft is 100 meter, so CG will be 20 meter from the reference point. Similarly CG YY, I'll just say if this datum is the center line 00, then could be 2 meter on it will be like plus 2 meter, denotes positive to the right. And similarly CZZ, let's say 1 meter, positive 1 meter, and could be written positive is up. So this is the data which is provided in the manual of the aircraft, and this is in respect of the empty weight of an aircraft, that is 4500 kgs, which is provided by OEM. And then there is a CG data, that is 20 mm plus 20, definitely plus if it is from the if the reference is taken at the nose of the aircraft. If it is at the center, let's say this is the datum, then it will be given as minus 30 meter or plus 20 meter. If here is this thing, if this is 00, could be like plus 20 meter can be mentioned in the manual, or minus 30 meter can be mentioned in the manual if this is the point. Or if this is the reference, then it will be plus 20 meters, stating the reference is at the nose. Similarly CG in the YY direction and CG in the ZZ direction. So this will be the data provided in this is an example, not a real, not to scale, nothing. This is just an example I've given, a rough example, just to give an idea how the body is mentioned is being balanced in all three plane, that is longitudinal, lateral and vertical. So I have taken this CG calculation. I'll give an example for that. So now how the CG calculation is done when we calculate the all-up weight of an aircraft. So all-up weight is the empty weight plus mission oriented weight of an aircraft. So let's say aircraft is going for a slithering operation, and rather it's an helicopter, or not slithering operation, it is carrying troops. This is a fixed wing aircraft, it's carrying troops, so it's carrying 5 troops. First we have to take the reference. Let's say this is the reference, and we are aware that the length of the aircraft is 100 meter. All the values which I am taking is just for the reference to make the picture clear how the CG calculation is done, and I'll be only explaining the longitudinal, and the lateral and vertical is being done in the similar fashion. So we are aware that 2 crew are sitting at 5 meter, and the weight I'll explain. So I'll just write alpha is here, and 5 troops are Bravo, Charlie and Delta. So 2 troops are sitting here, 2 pilot and co-pilots are sitting here, 2 are here and 1 is here. And let's say they are carrying a gear at point E. I'll say gear. Okay, let's see the distance. This is 5 meter, this is 10 meter, this will be 20, this will be 30, this will be 40. I'm just taking an example. So and we are aware that empty weight of an aircraft which is given in the manual is, let's say, 2000 kgs, and center of gravity in xx direction is at 20 meters. Okay. So if we have to do the calculation CG in xx direction, it is the moment of all the weight from the reference point divided by the weight of all the total weight. So I'll just take the crew weight is equal to 100 kgs each, and 10 kgs, just for reference, 10 kgs each, and gear is 5 kgs. This is all not to scale, not to measure, just an example. So let's calculate the center of gravity, how the center of gravity is shifting when we putting all this weight. So we are aware of CG in xx. First we'll take the empty weight, which is already calculated by the OEM, that is 2000 into, so we'll calculate the moment, that is 2000. I'll just, which is acting at the 20 meter, at this point only. So this is the point of the CG. So 2000 into 20 meter. Then we'll take separately. So at alpha there are 2 pilots, that means 20 kgs into 5 meter, plus then Bravo, which is at 10 meter, and there are two people are sitting, then 20 into 10, plus at Charlie C point you can see 2 people are sitting, again 20 into, but the moment arm is 20 meter, plus I'll just write it here, at Delta D point 1 person is sitting, 10 into, the distance is 30, plus gear is at Echo point E point, which is of 5 kgs, but the distance is 40 meters. So when we calculate the complete part, this will be 40,000 plus 100 plus 200 plus 400 plus 300 plus 200. So when we'll calculate, $41200. When we divide it with the total weight, so total weight we are aware that is 2000 plus 20, 20, 40, 60, 70, 75. So 2075. So if we divide it, we'll be getting that will be 19.85. So that means CG, which was there at 20 meter, now it has been shifted to 19 point. I'll take another color. So initially with empty weight as 2000 kgs, the CG was at 20 meter, but when we have 2 pilots sitting here, 2 crew sitting here, another 2 at Charlie, which will not affect any weight because it is sitting on the CG. Then there is 1 crew is sitting at the Delta point, which is 30 meter from the reference, and then there is gear, then their gear, which is of 5 kgs, which is positioned at Echo, which is at 40 meter. So the new CG with all this weight is 19.85 meter from the reference point. So that's how the CG is getting calculated. Similarly, when we go for the lateral one, so we have to check that how much weight is positioned on the either side, and then we have to calculate the CG similarly. So now coming to the last part. So any flight manual will have this kind of graph. As you can see, this is the box which is of major concern. So as we have seen that the empty weight of the aircraft was 2000 kgs, with which the CG in xx direction was, so this is a center of gravity limit in xx direction. Similar box is given for the yy and zz direction in lateral and this thing. vertical position. So CGXX was 20 meter. So when we calculate the all of weight, that was all of weight was 2075 after adding the crew and their gear. The CG was shifted to 19 point, I'll just check, 19.85. now we have to check in this graph whether the aircraft is designed with this shift of CG or not. So let's say this is for some specific, we have to check the weight. So how much weight, initially there is an empty weight also, and then the total all of weight. So we'll check, we'll have to see all of weight on a y-axis, and on x-axis the CG location is there. So if it is lying, if this 9.85 is lying within the box, then it is safe to fly. If it is shifting beyond, if it is going like, let's say the weight you are putting at 1800 kgs and the CG which should be at 31 32 is shifting below this, then it is not safe to keep the load. Then you have to position the load accordingly. So this is specifically for XX, similarly for YY and ZZ. So the whole point is to keep the load in an aircraft, in a way. Let's say one point is here, one weight is here, one weight is here. So if we calculate the total CG of the all of weight, then it should be within the limit of the box as provided in the flight manual. So here I conclude my video. I hope I have made the theory, made the calculations, how the CG calculation, weight calculation is being done in an aircraft. And if any specific doubt is there, please let me know. I'll definitely clear it in the comment section, or I'll make a separate video or small video on that topic. I believe I made things clear. So if you like this video and if you want to get updated with the aviation field topics, please be in touch, subscribe my channel, and we'll keep meeting through my channel. Thank you, thanks a lot.